I could say 3x plus y equals 5, and x plus 2y also equals 5. Now, I want to see what does x equal and what does y equal. Okay, if we have, so there's a couple ways you can do this. One way is that you find one of the variables in terms of the other variable in one equation, and then you substitute that expression into the second equation. Here's what I mean. Let's take a look at this equation. If I subtract 2y from both sides, I get x equals 5 minus 2y. Now, if x is equal to 5 minus 2y, I can go back in my original equation, and instead of x, I can write 5 minus 2y. Because they're equal. So I can always substitute one for the other if the two things are equal. So I have 3 times x, but now I know x is 5 minus 2y. And, 3 times x plus my y equals 5. So by the distributive property, this is equal to 3 times 5, which is 15, minus 3 times, well, I could think of this as minus 3 times 2y, so it's minus 6y. I could have changed this to plus and negative, in which case it would be plus negative 6y. Just equivalent ways of writing the same thing. Plus my y equals 5. So if I want to get the y's by themselves on one side and get the plain numbers on the other side so that I can eventually solve and see what y is equal to, then I would say subtract 15 from both sides, which means minus 6y plus y equals 5. And I'm subtracting 15 from both sides. That 15 take away 15 was 0. 5 take away 15 is going to be negative 10. So this is negative 6y plus positive, remember y is the same thing as 1y. Minus 6 and plus 1 of them is minus 5 of them, right? Because when I add a positive and a negative, I take the difference between their absolute values. The difference between 1 and 6 is 5. And I use the sign from the larger. So this is minus 5y is equal to minus 10. Because 5 take away 15 is a negative 10. Or to look at it another way, instead of thinking take away 15, think of it add negative 15. The difference between two numbers, where one is positive and one is negative, is the difference in their absolute values, and use the sign from the larger of the two numbers. That is to say, the larger absolute value, just the number itself, regardless of sign. All right, now, if I multiply by minus 1 on both sides, they'll change the sign. Minus 1 times minus 5 is positive 5. So this is 5y equals minus 1 times negative 10 is positive 10. So this is y equals 10 divided by 5. Because if I divide both sides by 5, which is the same as multiplying by 1/5, I get 1y, and 10 divided by 5 or 10 times 1/5, either way of writing it, the answer is 2. Okay? So if I go back now and I substitute 2 for y into either of these equations, I can see what x is. Well, actually, let's go back to here. X is equal to 5 minus 2 times y is 2. So 2 times 2. So x equals 5 minus 4. So x is 1. Now, check it out. Is that correct? If x is 1, 3 times 1 is 3, plus y, which is 2. So that's 3 plus 2 is 5. So the original equation is true with these values for x and y. What about the second equation? Will that be true as well? X is 1, so this is 1 plus 2 times 2 is 4. 1 plus 4 is 5 also. So this particular value for x and y make the original two equations true. And we did this by the substitution method. We went and took one equation and we solved for x in terms of y. Meaning, when I solve for x, I just really usually want to say x equals some number. But if I can't do that yet, I might get it, how many y's it equals to? Well, it's 2 y's, subtracted from 5. That's what x is equal to. And then I substituted that into the other original equation. Let's look at another way that we could have solved this problem. Now, if I take the second equation and I multiply both sides by 3, look what will happen. I'm going to say 3 times, and I have to be careful how I do this, because it's 3 times that whole quantity. It's not just 3x plus 2y. It's 3 times the quantity x plus 2y. It's the whole thing on that side. And I multiply the other side by 3 as well. We use the distributive property to say that this equals 3x plus 3 times 2 is 6y, and this is 15. So this is just tripling what we had in this second equation, right? So here we are. We have multiplied the second equation by 3. Now, I'm going to also multiply by -1. -1 times 3x plus 6y, the quantity, equals 15 times -1. This is -3x plus -6y equals -15. So this comes from the second equation, right? It's equivalent to the second equation. Now I'm going to add to this the first equation. Okay, instead of saying y, I'm going to say 1y. 1 times anything is itself, so I can always stick in a 1 like that. -3x and +3x is 0. So it's no x's. That term dropped out. We don't have x's anymore. -6y and +1y is -5y. So I've got -5y equals -15 plus 5 is -10. So y is equal to -10 divided by -5. Because I had -5, and I'm dividing both sides by -5. This just becomes 1y, and negative divided by a negative is a positive. 10 divided by 5 is 2, so y is equal to 2. Was that what we got the other time? Yes, y was equal to 2. Now, we can take y equaling 2 and actually substitute it into any of these, but it's best to go back to one of the original equations. So where we see a y, we'll put a 2. Let's do it here. 3 times x plus y, which we now know is 2, is equal to 5. This means that 3x's equals 5 minus 2, which is 3, because I subtracted 2 from both sides. So x equals 1. And that's what we found by the other method as well. X was equal to 1. So there's actually a couple ways that you can solve this. There's also a way to do it on a graph. There's a few different approaches, but we're going to leave it with this algebraic approach. Okay, thank you.